Hi everyone. Here's a little part 2 of lesson 21. See how many, we'll do another little 15-minute chunk here of problems. And we're ready to start with problem number 4. If you want to see part 1 for problems 1, 2, and 3, you should consider that video. Okay, so this is an F double prime graph on number 4. I want to know where F prime is increasing. So if we can ignore sort of the primes for a minute, if I want to know where a function is increasing, where is function increasing? Any function. We would look at where the function's first derivative is positive. If f prime is function, f double prime is the first derivative of f prime. I know it's a little weird because it's got a lot of letters. We've got the different numerations, but basically if I want to know what f prime is doing, and I want to describe f prime, f double prime is acting as first derivative. So, what do I see? I see a function that's positive, and then negative, and then positive for y's. Looks like it changes at 1, and it changes at 3. And it ends at 5. So f prime is increasing anywhere of double prime is positive, 0 to 1, and 3 to 5. These are all AP questions from past AP exams, so some of them definitely have little twists and turns to them. Let's take a look at number 5. 3 expressions. We have to figure out which one's the largest, which one's the smallest. Oftentimes when we're looking at this kind of problem, especially when we have 3 of them, it's that one of them would have to be negative, one of them would have to be positive, and one of them would be 0. And if we know that, then we can put them in order. Either largest to smallest would be positive, 0, negative, or smallest to largest, negative, 0, positive. But this question often isn't about exact value. It's about comparing 3 things, one of which would have to be positive, one of which would have to be negative, and one of which would have to be 0. So, first thing I do is if this is the F graph, f of negative 2 and f of 2 are both 0. So number 1 is 0. So 1's probably the one in the middle. And if that's all we knew, that this is what this problem is usually about, the fun thing is there's only one of these guys with 1 in the middle, and that's D. Let's look at the rest of it, though. F prime at negative 2. If we're looking at the F graph, the slope of the F graph is F prime. So F prime at negative 2 is positive, because there's a positive slope at negative 2. F prime of 2 is positive. So a positive and a positive is always going to be a positive. And a positive is always bigger than 0. So 2, expression 2 here, is greater than expression 1. So 2 should be ahead of 1 for sure. Oops. Yeah, 2 should be ahead of 1 because we're going to go big to small. So it should be 2 and then 1. So anything that doesn't have 2 and then 1, I threw away. Now, hopefully we can establish that 3 would have to be negative. So let's see if we can figure it out. F double prime. F double prime is concavity. And all you can do is either talk about it being positive or negative versus concave up and concave down. So it looks like F double prime at -2 looks like we're concave down around -2. So that's a negative number. Minus, it looks more like we're concave up at 2. So I have a negative minus a positive. That's going to just be more negative. If I have a negative number and I subtract a positive, I'm just going to get more negatives. Think about if you need to put something out, like write -4 minus 7. It's more negative. -12, -10 minus 12. More negatives. So 3 is negative. It's the smallest. So it should be at the end. So, yep, D is, as we suspected, was the correct answer. We're going to practice this kind of problem again. There's a couple different ways this problem gets asked, but oftentimes if it's a largest to smallest kind of question, it's about positive, negative, and 0. All right, number 6. G of x is f of x plus 4. This is f prime. We want to tell stuff about G. So if we want to figure out stuff about G, we need G prime. So G prime, if G is f of x plus 4x, G prime is f prime plus 4. So if I wanted to look at the G prime graph, it will look just like this graph, but moved up 4. So the point that's down here at 2, -4 would actually end up right there. The point that's at the origin would end up right there. And so this part of the curve would go like that. It would go up to 8 instead of 4, and then back down. Eventually it would cross the x-axis. But if you look, when I take f prime and move it up 4, a whole bunch more of the graph is now above the x-axis. Everything goes above the x-axis. This moves up, this moves up, this moves up. Everything is now touching or above the x-axis except something right down here. So I have G prime with negative and then everybody else positive. One relative min is all we're going to have on G. Now, I know videos are tough because you can't ask any questions. You can go back and relook at my thinking, though, and also remember I'm going to be available after school next week. Mr. Walters is available after school on Thursday the 8th if you want to go in and ask any questions about any of these problems. Okay. Number 7. This is probably the hardest one because we have a table instead of a graph. I'm still going to make a number line for my velocity. These are position graphs. And so I need to think about what kind of velocities I have and see how that's going to tie into slopes of position graphs. So the first thing I have at 0 is a velocity of 3. So at 0, I have a positive slope. And it looks like all of these graphs have a positive slope. But at 1, so they all start with a positive slope. But then I go to 0, and then I go to -1. So my position graph is positive slope, and then negative slope. So that would be a maximum at x equals 1. Not here. Don't have a maximum at x equals 1. Not here. All the rest, though, look possible. It's kind of like uphill and then downhill around 1. Uphill and then downhill around 1. Uphill, then downhill around 1. All right, let's see what happens after that. After starting to go downhill, after maxing at 1, I'm going to go uphill and uphill more. Up and more up. So somewhere between 2 and 3, there's a min, or a turn. Because we're going downhill. Position is going downhill because velocity is negative. And then going uphill again. So turning between 2 and 3. Here, turns at 3. And it actually even looks like it's still going downhill at 3. Here, it doesn't turn at all. Here is a turn between 2 and 3 and going uphill. Here is kind of a turn between 2 and 3 and going uphill. I think the numbers here will be the last thing that tells us. This slope should look a lot like that slope, and should be a little steeper than that slope. It's going up a little more quickly between 3 and 4 than it did from 2 to 3. Oh, 2 to 3 it's going. Wait. Okay, hang on a second. I'm already confusing myself. Let me make a number line. What's my velocity look like? My velocity is positive, and then 0, and then negative, and then positive, and then positive. So I should be looking at downhill, uphill, downhill, up, up. And why did I throw E out? Why did I throw E out? Oh, because it didn't have a max at 1. Oh, so E's already gone. Oh, I don't know why I'm still looking at E. Okay, it's D. I got confused. I confused myself. E was already gone because it didn't have a max at 1. Okie dokie. That's my least favorite kind of problem. Last thing for this section, true or false. This is another good one to practice. F prime, negative, positive, negative, changing at -1, changing at 2. So relative min at -1, true. F prime, negative to positive. increasing on -1 to 2. True. F prime positive on that. A local maximum at 0. False. F prime has a local maximum at 0, but F does not. F is concave down from 2 to 3. All right, let's talk about the concavities, or the slopes of F prime. So it's got a positive slope, and then a negative slope, and then a positive slope. Looks like we got a change of slope at 0, and we got a change of slope at 3. So 2 to 3 fits into the concave down interval. I'd say true. F double prime less than 0. All right. So that's going to be the end of this part of the video. The last part of the video, I'm going to do the last problem. I will see you there in a minute.